one of the ways that we had today, we're going to learn completing the square. Completing the square. All right. We might have had a problem that looked like this. Okay. Where does that cross the x-axis? It crosses the x-axis when y equals 0. So we would set that equation equal to 0. And this is what you had in your quiz yesterday. And we would, one of the ways was factoring, right? We could factor this. X plus 6, x minus 2, and then either x plus 6 equals 0, or x minus 2 equals 0, and subtracting 6 from each side. This is one of the methods we had. And so x would equal negative 6 over on this side. That's one way. Okay, by factoring. Something else that we had well, something like this. How many answers are we going to get here? 2, right? The x squared says we're getting 2 answers here. All right? And what we did here is we divided by 3. And then what do we do? Minus square root. X equals what? Plus minus. Okay, those are the 2 places where it crosses the x-axis. At plus or minus the square root of 6. That's our exact answers. And then we were able to go to our calculator and find out what the decimal value was, right? Okay. All right. Well, then. What would we do there? Yeah.
X plus 5 equals plus or minus the square root of 20.
Okay. So what we did here, we did this on your test yesterday, is we took the square root of both sides of this equation. We took this. Okay. The square root of this thing squared is simply x plus 5. And the square root of the right side would be plus or minus. Always plus or minus. And then what's our next step?
Minus 5.
Minus 5 from each side, right? And x would equal, remember what I said, we want to put this term first. So you want to put negative 5 and then plus or minus the square root of 20. All right? And that's where we're at so far. If we wanted to know decimal values, we could just put negative 5 plus the square root of 20 in our calculator. And negative 5 minus the square root of 20 in our calculator, right? And we could find 2 decimal values. Those are the 2 places where this parabola crosses the x-axis. All right, so given a problem like this, before we start now, we're going to do completing the square. This is all stuff we know. I want you to remember this. Okay? If I gave you an equation like 3x squared minus 2x plus 5, can you tell me what the A is? Not 3x squared. This is your A term. This is your B. This is your C. Remember ax squared plus bx plus c. That's going to be important. Okay. Let's take an equation like x squared plus 6x equals 10. All right? Well, if I subtract 10 from each side and try to factor it, it's not going to factor. So how do I solve that? I can't take the square root. I can take, I could subtract 6x. We can't take the square root. We have to have other methods to find out where this crosses the x-axis. It would be nice if I could write this, okay, if I could write this as x plus something squared, then I could take the square root of both sides, right? So what I want is I want to be able to add a number here. I want to be able to add something here that's going to complete the square. So I can write this as a perfect squared trinomial. And what number do you have to add? What do you think? All right, now there's going to be a process, and let me show you that process. Step 1. And this is to complete the square. And I'll do a number of these problems, and we're going to use the same, like this 3-step process. The first thing we do is we take 1/2 of the b term. The b term is 6, correct? Half of 6 is 3. That's the first thing we do, take half of that. The second thing we do, then after we take half of the b term, square it. The third thing we do is we add that number to both sides of the equation. This is a little bit involved. It's going to take us a couple days to get through this. All right, so let's see what we do. Half of the b term, step 1. We said that was 3, correct? Square it. 9. The third thing we do is we add that number, 9, here, and here. We add that number to both sides of the equation. We can do that, right? You can add same number to both sides of an equation, or subtract it, right? Awesome. Okay. The reason we do that, if you remember from chapter 9, that is called a perfect trinomial square. And when you factor it, it factors into x plus 3 quantity squared. So I had to add a number to complete the perfect square. Now it's a perfect square. If I multiplied x plus 3 times x plus 3, I get x squared plus 6x plus 9. And 10 plus 9, 19. That's the method. Okay. Now I've got a problem like this. And this we know how to solve. We square root both sides. Plus or minus 19. And we subtract 3 from each side, which is the square root of 19. So x equals negative 3 plus or minus the square root of 19. You can do it. All right. Let's do it again.
I have a question.
Yes.
Before you put the 3 in there, like when you wrote the x, this, like where you said x plus 3 squared equals 19.
Mm-hmm.
Before you wrote that, I thought it was 3 before you did the problem because 3 times 2 is 6. Do you see what I'm saying?
Yes.
So do
You mean
have,
3 times 2, you mean if I multiply these two together and double it, I get 6?
Yeah.
That's exactly right.
Okay. So do you still have to do that method to get the 19 part?
Yes, because you have to know what number you can add here and what number you can add over here.
But 3 squared is 9.
That's correct.
Yeah.
But how are you going to know to add 9 over there?
Oh,
Okay.
yes.
Yeah, you could get to this point, yes, but can you get to 19? You know what I'm saying?
Mm-hmm.
Yeah. When you get really good at it, you will know, you'll be able to make those shortcuts, you'll know. All right?
Mm-hmm.
Let's take another problem. Did you guys write down this 3-step process?
Yeah.
Right there? Okay, let's take a look. Let's take another problem. All right. Now, the problems I'm going to give you today, our A term is going to be 1. Because this is the only way we can complete the square. If this first term is if the A is 1. So let's take x squared. Let's make this a minus this time. Yeah.
So if for some reason, like if we had 2x squared, then we cannot complete the
We
square.
have to do some other things before we complete the square.
Oh, so it's still possible.
We'll save that for later, yes. It is still possible, yes. Okay? So let's say 12x minus 7 equals 0. All right, what do I do with that 7? Let's put it over on the other side. Let's take that 7, which is called a constant. Let's take that 7 and let's bring it over to the other side of the equal sign. And we do that by adding 7 to both sides. The more work you show, the less mistakes you make. So I have x squared minus 12x. Notice I left a little room there. Because what number am I going to add? Now, Emily,
Yeah.
what do you think I'm going to have in my parenthesis here? Keep in mind, this is where we want to get to. Yes, okay, yeah, good. Some of you are picking that up already, -6. All right, so what number do I have to add to complete the square? Step 1, half of 12, -6. Square it, 36. That's the number that I'm going to add to complete the square. This number is always positive, by the way. If I add 36 here, I have to add 36 here. Whatever you do to one side of the equal sign, you have to do the other. What that allows us to do, because now this is a perfect square. It's something times something. And I think some of us picked it up already. It is x minus 6. Half of that goes in the parentheses. Okay? 7 plus 36. And that we know how to solve. Square root both sides. Equals what? Plus or minus? You with me? Add 6. And x is equal to 6 plus or minus the square root of 43. That's a method of completing the square. Okay. I want you to try one. before you try to complete the square, what is the first thing you do? Say it out loud.
Subtract 13.
Okay, that's your first step. Subtract 13. Go. I'll give you a about a minute or so. See what you come up with. While you're working on that, I think I will pause the recording. The ones I'm going to give you today are going to be relatively easy. However, the more we do, like tomorrow, we're going to do the same thing, the same method. But what happens if we have something like this?
But you can't get a
Yes, you would add the 3 first.
then you would have 3.5 squared.
So half of the B term is
3.5.
3.5. But what I'm going to have you guys do is you're going to use fractions. And so half of 7 would be 7 over 2.
Which that would probably be easier.
It is easier.
Because that would be just 39 or 49 over 4.
49 over 4 is correct. Let's do this. Let's play this one out. All right? This is the first thing we do. Okay? Half of 7 is 7 over 2. That means that in my parenthesis, it's going to be x plus. Now, if this were a minus, this would be minus. 7 over 2. Okay, squared equals. But let's finish this because I have to know what to add over here. So if you take 7 over 2 and square it, 49 over 4. 7 squared is 49, 2 squared is 4. That's the number that I have to add both sides. Now I can write this as a perfect trinomial square. And what's 3 plus 49 over 4?
3 plus
51 over 4?
Well,
I got 50.
well, you could write it as a mix. It wouldn't be called a mixed number and just have 349 over 4. But then if you were to solve it, you could.
Look, I know we don't want to write it as a mixed number. We don't want to write this as a mixed number because we don't want to take the square root of a mixed number. It's too confusing. And I don't want to take the square root of a decimal at this point. Now we take the square root of both sides. X plus 7 over 2 equals plus or minus. Well, let me show you how to do this. A little extra step here. Plus or minus the square root of 61 over the square root of 4. And the square root of 4 is 2. Now all I have to do is what I did before by subtracting 7 halves from each side. X then is equal to the negative 7 over 2 plus or minus the square root of 61 over 2. Can you handle that, Mario? Yes.
How did you get 61?
3 times
The reason
4.
we got 61, and what you can do, if you get confused on fractions, if I have 3 over 1 plus 49 over 4, I need common denominator. And the common denominator is what? 4. between 1 and 4. And I can tell Ms. Fondue this. I feel that as a school, this is the weakest part of our curriculum right here. It's fractions.
Yeah, because we did like weird brownie, like things that don't even make sense through kids. Like
I understand. So, the common denominator is 4. And isn't 12 over 4, doesn't that equal 3?
Yeah.
To get the common denominator, I have to multiply 1 times 4. So I have to multiply the top by 4. And when you add those two together, you get 61 over 4. If you have a calculator, 3 plus 49 over 4. You can go to your math program. All right. So that's how we get 61 over 4. Okay? All right. Okay. Do not leave this classroom without doing as many of these problems as you can. If you come here tomorrow without doing any of the problems, okay, stay up there, please. Should we go to the office? 12 through 18. A lot of different ways, and I went through all the different ways to compensate. There's factoring, there's rep, tables, same thing. Same thing. Didn't equal my office. Nick, don't bother me. Just take the test.
Are you buying? No, I was you don't either.
I would do it as well.
Oh, no, I didn't do that. I left it like that. So, yes,
Yeah, yeah.